This is a micrometer screw gauge, and it has different parts which the user is supposed to know. Now 0.25 millimeter, it means it can measure up to 0, that is the range of measurement, and then 0.01, that is the least count, that is the degree of accuracy of this micrometer screw gauge. There are different types of micrometer screw gauge depending on the division on the thimble scale. The movable part, this one here, this part here, this is what we're calling the thimble, and then there's scale here, so we call it the thimble scale. Now you can able to see inside here there is also a scale here, and this one we call it the main scale or the sleeve scale. This part here, these are the jaws. So if you want to measure the diameter of an object, or at the end of this lesson you're able to understand how to measure the diameter of a spherical object like the one that I'm having here, the marble, or even the diameter of a wire, mostly commonly used in electricity. If you want to find the resistivity of this wire here, we will have to know its diameter, and during electrical experiment you will be required to use a micrometer screw gauge to measure its diameter. So we should be able to understand how to measure the diameter by the end of this lesson. Now if you want to measure the diameter of, for example, of this marble here, to measure the diameter of the marble, we are supposed to insert this or put it between the jaws, the fixed jaw and the movable jaw. And how are we supposed to do that? We are supposed to be able to move. We are not advised to be using the thimble to move the thimble scale. We are supposed to use this part here, which we are calling the ratchet. So we're supposed to move. Now once it is inside there, so use the ratchet until you hear that clicking sound. When you hear that sound, that is the nerve. So probably if you use this particular part here, if it is a wire, you may find yourself compressing the wire, and therefore the reading that you're getting may not be as accurate as required. So we use the ratchet. The ratchet will be able to guide you. When you hear that sound, that means that is where you're supposed to take the reading. Now you can able to see here clearly there are two scales, as I've mentioned before. There are two scales here. This is the main scale and this is the thimble scale. We are going to consider both the scales when measuring the diameter of the marble. But then before we take the measurement, we need to be aware of the zero error. Now, before taking the measurement, you need to consider the zero error. Now, the zero error can either be positive or it can be negative. When the zero error is positive, you subtract from the reading from the measurement that you've taken. If the zero error is negative, you add to the reading or the measurement that you've taken. So before we measure the diameter of this marble that I've shown you, then we need to check if this instrument, the micrometer screw gauge, is having a zero error. Now, the zero error actually is the main source of systematic error. It is an error that if you don't check, your values will be inaccurate and you may not know the reason why, even if you understand how to use an instrument. So to eliminate that, we need to ensure that the instrument we are using is showing a zero reading. Now, if it is an analog like this, we have to check if there is no reading. If it is a digital meter that we are using, or a digital instrument that we are using, then check if it is showing 0 reading. Now, for this instrument, for the micrometer screw gauge to have no 0 error, then this line here on the main scale should coincide with the 0 on the thimble scale when the jaws are closed. Now, let me do that. Then we see. So the jaws are closed. The jaws are closed, and then interestingly, you can actually see on the main scale, you can able to see this line, and this line actually coincide with this 5 here. So it means that this micrometer screw gauge is already showing some value. Look where the 0 is. Look at where the 0 is. There is already value that is being shown at 5. So this is a positive reading. This is a positive 0 error. So the 0 error, sorry. So 0 error here is positive 5. But now we don't try to remember it is on the thimble scale. So if it is on the thimble scale, we are going to multiply by 0.01, which I'm still going to elaborate why. So the 0 error here will be positive 0.05 millimeters. So let's now take a reading of the diameter of this marble here, and then we see how we use the micrometer screw gauge to take the same. So here's the reading. We are going to take the reading here on the main scale and then the thimble scale, and I'm going to guide you one by one what to do. Now on the main scale, you can able to see here, this is 0, 5, 10. So it means that these upper divisions here represent 1 unit, which represent 1 millimeter. So this is 0, 1, 2, 3, 4 until 5. Of course, you can able to see 10, and then there's 15 there. Now there's these smaller divisions down here. What it means that this is 0, and then this is 0.5. This is 1, this is 1.5, 2, 2.5. That is how we take the division. Now, it's always good to understand the division of the scale that we are using before you take any measurement. So to take the reading on the main scale, we are supposed to read a value on this scale here that is just before this rotating part, which is the thimble. So you're supposed to take the measurement. So this is, you can see this is 10, and then this is 15, and you can able to see there is no other value down here. Let's look at it clearly. There is no other value, so it's actually exactly 15. So it's 15. That means that the main scale reading is 15 millimeters. 15 millimeters. Now the next reading is the thimble scale. Thimble scale reading, and let's find out how we take the measurement on thimble scale reading. Now thimble scale reading, that is the scale on this value here, we are supposed to take a value that coincides exactly on this line on the main scale reading. So we take a value that coincides exactly on this horizontal line on the main scale reading, and as I can able to see, it is actually, this is 20. You can see 20, so this is 20. So that is 20, so we take 20, we multiply by the least count, 0.01 millimeter, which is indicated here. This is the least count of the micrometer screw gauge. So this should give us 0.20 millimeter. So we're supposed to add, so the diameter of this marble, diameter of the marble is given by 15 millimeter plus 0.20 millimeter. 15.20 millimeter. But then remember, actually this is, let me just call this as the reading. So this is the reading because we have not included the zero error. So there is just the reading, we have not included the zero error. So the zero error, which I showed you how to find, is positive. That means now the diameter of the marble is 15.20 millimeter minus 0.05 millimeter. This gives us 15.15 millimeters. So this is the diameter of the marble that we have just gotten. It is always good to repeat the experiment. You can just rotate the marble and then find the diameter of the other part. Even though it may look so perfect to be, it may look so perfect as if it is a perfect square, but probably it may not. Let's take another reading. Now we can now say that the diameter of the marble is the average of what we have measured. By repeating the experiment, we eliminate the random error. So this will be 15.22 plus 15.24. But then if you look at the first value, it was a little bit it's a little bit much different from this, but now that the 15 value hasn't changed, so you can just add this 15.15, then whatever you get we divide by 3. So this is 15.22 plus 15.24 plus 15.15. What happened? 15.22 plus 15.24 plus 15.15. You get that, you divide by 3, you get that. So now what you get here, you can able to see when taking measurement, we are supposed to give our answer into 2 decimal place because that is from the accuracy, that is 0.01 millimeter. So this will give us 15.20 millimeter as the diameter of the marble. Remember, you only do for A level, that is Cambridge, when you're doing experiment, if you're asked to measure the diameter of any given object that you've been given, it is always good to repeat the experiment. At least show that you've taken more than at least one reading, and then you find the average to eliminate the random error. And then you're supposed to check for the if there's any zero error, so to eliminate the zero error. But then in 844, probably you just be given one space or just a small space for you to work out. So you can find the average, and then you can take different measurement and then find the average later. So we have mounted nichrome wire on millimeter scale. So what I want us to do, our main focus here today is how do you measure the diameter of the wire, of the resistance wire that is provided with to you maybe during experiment. Again, to improve the level of accuracy of your measurement, you need to take the reading, the diameter of this wire in different parts. As you can able to see, this wire, to the eye, it may seem to be, we may assume that it makes a perfect cylindrical shape, but it's not. Some part which you may not be able to see can be having a smaller diameter as compared to the rest. So to get accurate reading, at least we should be able to take maybe 3 different measurements on the different parts of the wire. Then we find the average. Of course, clearly you can also see that the wire is not as straight as it's supposed to be. That can also be something to note as you're taking the reading. So let's continue. So the first thing we do, of course, we know you have the jaws here. We just have to put the wire between the jaws. Then we close it using the ratchet. Okay. Now on the main scale reading, you can able to see this is showing 0. So there is no other value. There is no other value before this rotating part of the thimble on the horizontal line. So there is only 0 here. There is only 0. And so on the main scale reading, we have 0.00 millimeters. But then on the thimble scale, you can able to see the one that coincides exactly with the horizontal line, and that is, this is 45, so this is 46. So this is 46. Now the main scale reading, there was 0.00 millimeter. Then the thimble scale, as you have seen, that is 46. We multiply with the least count, 0.01, which gives us 0.46 millimeter. So the reading will be this plus this, which you're getting 0.46 millimeter. So the diameter of the resistance wire on one part that we have measured is 0.46 minus the 0 error, which we found to be 0.05. So this will give us 0.41 millimeter as the diameter of the wire on one particular point. So I want us to repeat the same, then get different values. So once again, we insert the wire in the jaw. Don't stretch the wire that much. Then until you hear that sound, then you take the reading, the millimeter. So once again, you can able to see there is 0 reading. There is 0 reading on the main scale, and then the value that coincides with the horizontal line, this is 45. So reading 3, we have the main scale reading, which is 0.00 plus that is the thimble scale, which is 45 times 0.01, and this gives us 0.45 millimeter. So the diameter D will give us 0.45 minus 0.05, the 0 error, which will give us 0.40 millimeters. Remember, if you write 0.4, you'll be awarded 0 because the least count, the degree of accuracy of micrometer screw gauge for the one that we're using measures up to 0.01 millimeters. You now know how to use a micrometer screw gauge. I wish you all the best and stay tuned for the next video. If you have a question, kindly drop it in the comment there.